The recording has started. Welcome to the day one of DevOps hands-on training. So, in the last Thursday, okay, we had our day zero. Okay, it's kind of an introduction of what we are going to go through in the next coming 25 classes or 23 classes. Okay, approximately 23 classes. Sometimes it may get beyond 23 classes. So, day one. Okay, this is the official start date of our training. Okay, today is what we are going to start with the content. Okay, so let me skip to the content directly. Okay, so the first thing that we have to understand, okay, in any course is how, okay, why and how, okay, we are learning this. Okay, for example, how did DevOps evolve over a period of time? Then we'll understand where we are today. Okay, so let's understand how DevOps has evolved, and also we'll try to understand the definition of DevOps as well today. And also we are going to introduce about cloud computing as well. Okay. Okay, so this is the high level overview of how it got started. It may not make any more relevance how it was before, but we'll better to good understand how it was during, okay, before 2010s, how it was, and now it is how it is. Okay, it's better to understand, get a picture. Okay, so before 2010, okay, we call it as traditional software development approach. Okay, before 2010 period, okay, we were having monolith applications. I will explain what is monolith and what is how operations team used to work in that period. Okay, I will explain with diagrams. And okay, this is how it was before 2010s, monolith applications. Okay, just remember this, and I will come back to this later. Okay, and operations team is nothing but the team of members who are managing those applications. Okay, managing those applications. Okay, in production environments. Okay, they are responsible for managing these applications in production environment. Just remember that. Okay, there were the applications were called as monolith applications, and a team of members were operating these applications in production environment. Okay, that was what happening before 2010 period. Okay, after 2010, there is a big shift in the architecture, application architectures. There are several reasons for that. Okay, so why there is a sudden shift after 2010s or early 2009, 2008? It started in 2008. That shift started in 2008. Why? Because okay, the cloud, Amazon started with Amazon Web Services in 2007-8 period, and some of the companies have started adopting those, okay, cloud platform, okay, services. Okay, so that's why, okay, there is a shift in the mindset, and there is a shift in architectures, there is a shift in processes. Everything started during 2008, 2009. And if anybody can tell, whoever has done some googling, okay, if anybody can tell who are the first companies that were adopting DevOps, anyone who can tell what are the first few companies that started adopting this DevOps culture? We'll discuss anyway, but if anybody aware of it, just ping me in the group, or you can unmute and talk about it. Okay, if not, we'll move on. Okay, so yeah, the one of the first companies was Netflix. Okay, the first companies which were adopting this DevOps was Netflix. Okay, Netflix was experimenting with something new architecture called microservices. Okay, microservices. That was okay. It's an experimental period for Netflix. Okay, Netflix was a startup, and it was experimenting with something called as microservices. Okay, and also agile methodologies were becoming very popular during that period. Okay, they want okay, agile has, okay, picked up during that period. Everyone wants to be agile. They don't want to have a waterfall kind of an approach. We'll see what is waterfall and all, and some of you may be aware of waterfall already, but we'll discuss that. Okay, so that's the reason a new architecture has evolved. Okay, we'll see what is that new architecture, what is the difference between microservices and monolith architectures. Also we'll understand. Okay, because of these changes, a mix of operating system, the culture, okay, the team that is operating these applications also changed. It has become a mix. Okay, some companies are using operations team, and some companies started using DevOps culture already. Okay, example Netflix. Okay, now, so that's how it started during early 2009 2010 period, and later on it stayed like this for some time. And now, okay, today's world, most of the companies, not every company, but majority of the companies are using Agile plus DevOps methodologies, okay, and they are using microservices architecture, and the teams that are operating these platforms are called DevOps teams, okay. Sometimes they are called as platform teams, DevOps teams. See, we'll get confused when we see the kind of roles that are getting posted, okay. So DevOps was the terminology that was used, okay, during 2010 to 2024 until 2020s period. Now some companies are using platform engineer, okay, some different roles are coming into picture, DevSecOps, DevOps, okay. So different names are getting used. If at all you are confused when you are going through these opportunities, just ping me, I will clarify whether it is suitable for you or not. Okay, I can just quickly check and tell you whether that is a suitable role for you or not. Okay, so this is how it has evolved. Okay, at a high level, this is the evolution of DevOps. Okay, it started with operations team and micro monolith applications, but it went on to microservices based architecture with agile and DevOps methodologies. Okay, this green color box is the methodologies. Okay, DevOps, agile and DevOps methodologies, and in the bottom we can see microservices architecture and DevOps. Okay, teams working. Okay, using these principles and architecture. Okay, now let's get into the okay traditional approach and okay, so yeah, traditional approach versus, we'll understand monolith versus microservices as well. Okay, let's start with this one. Okay, so what are the different teams that are involved in any project? Okay, just at a high level, there are more teams than this involved. Okay, just for brevity and for understanding it better, we are trying to understand what are the different teams that are involved in the projects. The one of the teams that is involved is business teams. Okay, and another team that is involved is the domain teams. Okay, which have developers. Okay, for example, they are experts in creating and delivering projects. Okay, these guys are experts in business. They know how to bring projects and how to deliver some get the business requirements, basically business teams. And operations teams are good at managing these applications. Business teams wants to deliver value to the end customers. Developers wants to create new features. Operations team wants to make sure that applications are stable and available for always. There are no okay, there are no like unavailable. So always applications have to be available. Okay, so they have to make sure 100% availability. Okay, and how this can be done? By making sure that whatever that is working fine, they should not touch it. Okay, that means we should have minimum changes. Minimum changes. Okay, so what, see, these the intentions of business team and operations teams are quite opposite if you see. So operations team want to minimize the changes, whereas business team wants to deliver high value to the customers. Okay, conflicting interests. Okay, so we have to strike a balance between these two. Okay, so that is the main idea. But in the traditional approach, okay, we have this kind of a model in the software development life cycle. Okay, we have this kind of a model. What is this model? In traditional software development, okay, life cycle approach, we have this okay, we have this model where it is okay, waterfall method. Okay, this method is waterfall method, waterfall approach. Okay, so where the requirements they will be first captured, then we work on design, then we work on implementation. The we means there are different teams working on these things, right? As we told before. So requirements are captured by the business team. Okay, this is one layer. And there is another layer, which is the domain teams who are experts in delivering the projects, the design, implementation, testing. Okay, these three are done by domain teams who are experts in, once a requirement comes, they know how to deliver the project. Okay, that is their expertise. Okay, so next thing is the deployment and maintenance. So this is the operations team's activity. Okay, so in the traditional world, this is how it used to happen. Okay, first requirements, then it will be given once all the requirements are captured. Okay, it will be given to the design, to the domain teams, so that they can design, implement, and test it, and then deliver it to the operations team, so that operations team can deploy that applications and deliver it to the customers, and they can maintain the applications in the production environment. So this is how it was done. Okay, but there are some problems with this one. Okay, so which we'll discuss. Okay, in the diagrammatic form. So before we discuss this, so I will show you how. Okay, so this is how. For example, let's take an example of a retail application. Okay, retail application means, Walmart, or Walmart delivers. They provide something similar to Amazon.com, right? They will also have a retail web application, which can where we can purchase products. Okay, purchase different types of things from their websites. Okay, so, for example, let's say we are also trying to build a new product that is a competitor to Walmart or Amazon, but we are mainly concentrating on health domain, for example. Okay, that is the main difference between what we are trying to deliver and what they have currently in market. Okay, Amazon or Walmart, or all those products they have their own differentiation, and let's say we are trying to build our own health related products, retail application. So if you follow this software, whatever the waterfall approach that we have, in this approach, if at all we want to deliver some value to our customers, if at all we want to deliver value to our customers, how it can be done. Let me show that diagram. I'll try to find the diagram quickly. Okay, I'll put it here. That's better. Okay. So let's say I will take this one. Okay, I'll put it here. So now in this model, if I have to deliver a project, so I can't, in a so we have something called as monolith architecture, which we'll discuss soon. Okay. So if I have to deliver a project, first of all, I have to be clear with the requirements. What are the requirements here? Okay. I want to deliver health related products. I want to demonstrate in health related products. I want to display in my retail application. Next, it has to support some payments. Okay. Next, it has to have a feature where we can purchase health related groceries. Okay, purely health. Okay, maybe non-chemical. Okay, organic groceries, for example, electronics products like BP machines and other stuff. Okay, so these are the requirements. Okay, first somebody has to provide me with the clear requirements of what are the features we want to deliver. So this is the first thing, requirements. Okay, first thing is requirements. Let's put that. Okay, let me change the color. So this is the requirements that we are working on. And then, during quarter 1, what we'll do, we are going to work, our business team is going to go do market analysis and find out what are the things that our company has to deliver to become successful, even when big players like Amazon and Walmart and other companies that are in the market are doing. They do the analysis and they come back and say, okay, if we do this, if you deliver these kind of features, then we will get better value in the market. Okay, that's what our team is doing. Okay, so once the requirements are clear, as I told you before, what then we'll be giving this requirement to our we'll be giving this requirement to our domain teams. Because there are some domain experts. Domain teams will be there who can deliver this project. Okay, so what these domain teams will do, the domain teams are going to do the design. Okay, let's say design is taking some time. Okay, design, because they have to design for all these features. Okay, so brackets, let me put the brackets here. Okay, they have to design for all the features here, like this. Okay, they have to design for all the features that we have captured here, because we want to deliver a competitor to the existing retail applications. We have to first design an application that can compete with the existing products in the market. Then what will happen? Then we are going to implementation for all these features. Implementation. Okay. Then we have to test it. So generally implementation is very takes a long time compared to design and the requirements. Okay, the implementation is the longest one. Okay, out of all the software development lifecycle stages, implementation is the longest. So it may go beyond 1 year of the effort here. If you see here, see in the bottom, what I'm mentioning is the timelines. Okay, is the timelines. Okay, I'll show the timelines once again. So if you see the timelines here, Q1 is 3 months. 3 months. Each quarter is 3 months. Q1 we are working on requirements. Q2 we are working on the design, and once we are comfortable with the design, then we are going to involve our domain teams, development teams, to work on the implementation. Okay, domain teams again will be involved to work on the implementation. Okay, so in this period we are not making any revenue, as you can see. Okay, we are not making any revenue, no revenue at all. Okay, let me put that. Just a minute. I'll strike this off so that we are clear. No revenue at this point. Okay, no revenue at this point. Okay. No revenue at this point. No revenue at this point. Okay. So now implementation, as you can see, it's going until Q4, maybe Q1 of next year. Okay. Then testing effort will be there to test whatever the features that we are delivering. Okay, testing may take 1 quarter because there are so many features. So testing, that also will be done by the domain teams. Okay, domain teams will do the testing as well. Okay, so testing teams will be involved to do the testing here. Okay, there also we don't have any revenue as of now, because we are still working on the product. Okay, so now we are in the last phase, which is once the testing is completed, we can deliver the value to our customer. Okay, let me put this quarters also here. Okay, here. Okay, so we are delivering, our testing team is working on it. Then we are going to work on, once the testing team is comfortable, then we are going to work on deploying these applications into the market. Okay, so our operations team will be involved here. Okay, this is before 2010s. Okay, so operations team are going to pick up this work and they're going to deploy. Okay, the finally. So deployment. So the overall process, if you see, okay, here, this is operations team, domain team, and then operations team will come into picture here. Operations team will come into picture here. Once they deploy, that is when we are going to make money. Okay. See, this is a long process if you see. Okay. After 1.5 years, we are delivering value to our customer. Approximately after 1.5 to 2 years, we are delivering value to our customer, and then we are making money. Until then, whatever the investment that our investors are making, okay, we are using only to develop applications. Okay. And during this period, if anything is a anything, there is a problem in any of the phases. For example, okay, we started with design, then implementation, then during testing, we identified that there is a requirement gap, and we are not satisfying some of the requirements that, okay, captured by our requirements team or business team. Testing team identified that, let's say, then we have to go back to our, okay, go back to our business, and we have to correct few things here if you see. So that is the main problem here. So it's a again a big cycle. If at all you have to do some corrections, as you can see here, okay, it's a big cycle. Almost we have spent 4 quarters trying to build something, and we identified that there is a problem in what we have built, okay, and what we have created as a team. Then again, this process of correcting the requirements or correcting the design has to happen. Either it has to be corrected in requirements or it has to be in the design. Then again, implementation has to be done. Then again, we are wasting around 2 to 3 quarters again correcting correcting some of the project work. Okay, so this is a traditional application where, okay, where all the requirements we work on at the same time. Okay, all the requirements we work on at the same time, and this is called as monolith. Okay, this is the monolith. Okay, so let me put that here. Okay, so let me put that. So this is monolith. Okay, so this is monolith application. I will explain. Okay, monolith application. This is the monolith application where every feature, okay, is going to be delivered, okay, together, and we have to work on all the implementation and everything together. This is how, okay, monolith applications used to exist, okay, and they are delivered together. Now this diagram will make sense. Okay, I will show one diagram now. Now I hope you understand what is monolith, where we are going to work on all these features. So let's say monolith, okay, is this one. Okay, this red color one, I'll put the red color one. Okay, here, this is monolith. Okay, this is monolith. This cube is monolith. Okay, see here, monolith. Before 2010, what used to happen is, let's say we are delivering an application, which is a retail application, which is a competitor, which is providing all the health related features in the retail application. Okay, we are going to put all this together into one big application, monolith definition. You can Google it. Monolith means, okay, big structure, I think. Okay, so monolith, okay, we is going to have all the features together, and this will be delivered. Okay, this will be, okay, this application is going to be owned by DevOps, today's DevOps engineer, and we used to call them as operations team. Okay, operations team, or okay, or today's DevOps engineers. Okay, today's DevOps engineers, operations teams are today's DevOps engineers. They used to take these applications, and they are going to deploy to these servers. Okay, these are the servers that are going to host these 8 or 4 features, and then the customers here, this is the customer, they are going to use these applications that are delivered in the servers. Okay, so this is the end-to-end delivery mechanism where we are going to go through all those phases. Okay, these are the phases that we are going to go through. First, requirements, then domain teams are going to design, implementation, okay, testing, and then operations teams are going to take that application and they are going to, okay, deploy to the production. Okay, So now what is the problem here? Okay, so we saw one problem when testing team is testing. Okay, let's say they are testing it and they identified an issue with one of the feature or something, there is a problem. Okay, then we can't, okay, see, the problem is we have to correct it. To correct it, we have to go through these phases again. That is the main problem. Design, okay, first requirements have to be corrected or design has to be corrected, either one of them. Then implementation has to be corrected. Then testing team has to test it again. Then operations team has to operate it in the production. And if you see, the operations team is like not at all aware of what is happening until quarter 2 of next year. Okay, if you see here, operations team or today's DevOps team, they are not at all aware of what is happening, what our team is building, okay, until 1 year. See here, if you see, let me minimize it a bit. Okay, so if you see here, our DevOps teams or operations teams are coming into picture in the before 2010 period. Okay, the operations team are coming to picture here, quarter 2 of next year. And when we started the project, quarter 1 of this year, let's say, next year, quarter 2 only, operations team is getting involved here. So that means there is no visibility to our operations team. And with the pace at which our infrastructures are changing, okay, in today's world, this is not at all, okay, suggested. Okay, operations teams were not at all involved, okay, until 1 year means there will be so many changes in the infrastructure also. So those kind of issues are there. We'll come back to that. But yeah, now coming to the, let's ignore the operations teams problems. But if any problem is there with this one, okay, we have to rebuild the whole package. We have to rebuild the whole package, this red color one, and then deliver. That means another 6 months to 8 months of effort will be gone waste. Okay, unnecessarily everybody in the team has to wait until this period before delivering the next version of the corrected version of the application. This is a long cycle. Okay, before 2010s with monolith. Okay, with monolith. Now, what is the current, okay, what is the solution for this one? Okay, what is the solution for this one is microservices. Okay, so we'll understand this concept and then we'll go back to our presentation again. Okay, so what is microservices? Okay, microservices is a new architecture that has evolved because of Agile and DevOps. Okay, so because of Agile and DevOps, Agile methodologies and DevOps, microservices architecture has become very popular after 2010 period. And as I told you, Netflix is the first one. Okay, for one of the first few companies that have started using this, adopting this architecture. Okay, so what is this difference? Okay, as you can clearly see, each feature, okay, let's say we have one feature called health related products to be displayed in our retail application. So in this architecture, health will be created as one separate application. Okay, as you can see here, it's a separate application. Okay, I will give you some analogy, real life analogy as well. Okay, so I will give you that. Please hold on until I provide that one. Then it will be very much clear. Okay, so now payments, we have second application, groceries, third application, and electronics, fourth application. So everything is a small service or micro service. Okay, now the analogy part. Okay, so this one, each one is like, okay, for example, if you have purchased your mobile phone, okay, in today, when I purchase an iPhone or an Android phone, okay, so I get nothing, right? I get nothing. Very few applications will be there. Let's say, okay, for example, if I have to do some payments, I download a payments application and do the payments. Okay, if I want to purchase something from online, I will okay, install another application from App Store. Okay, if I want to buy something from, okay, some electronic store, I install electronics, like an app for electronic store application. Okay, so like that, everything is a in an app store. Everything, for every feature we have different applications. For my Facebook is one application which is for friends, connecting with the friends. Instagram is separate application. So like that, you can imagine, okay, all those applications in your app store as independent applications, right? Similarly, okay, when you are working with microservices, even if it is a combined application, okay, when for a end consumer, it looks like a single application. Let's say if I create my, okay, web, even Amazon.com or okay, Walmart.com, they're all looks like a single application, but in the background, they're all created as microservices, small applications will be created internally, but it will be looking like a single application in your browser. That is the difference actually. So for customer, there is no difference. Okay, customer, they see Walmart.com or okay, Google or Amazon.com, but internally they are delivered as individual applications. Individual applications are microservices. So that is the microservices architecture. I'm now comparing to the real life example. Okay, for example, as I told you, just imagine you bought a phone, and once you buy a phone, okay, you have nothing in your phone. Only few applications will be provided based on your requirement. Okay, you download an application from the app store and you install it. Okay, so now, okay, because you know what to use, you are installing those applications from the App Store. Okay. So each application that you are installing from the App Store can be imagined as a microservice. And that is all these microservices you are installing from your App Store. They are to serve whatever the requirements that you have, right? As a customer of the phone or as a consumer of the iPhone or an Android phone, you have some requirements. I have to book tickets online. I have to do some payments online. I have to purchase some products online. Okay, I have to learn some things online. So you have different requirements. Based on those requirements, you are installing your applications, right? You are installing your applications from App Store. Similarly, let's say I'm okay, I'm as a product manager or a product owner. I'm delivering a retail application. So what and all the microservices that are required for that retail application, I'm going to deliver that as a pack, deliver that as microservices, and all these microservices will be combinedly used in one web application. Let me put that also. That is the front facing for the customers. Okay, let me put that so that it is clear. Okay, so these are all the microservices, health and everything. Okay, let me. Okay, these are all the microservices. But to view this, okay, okay, to for the customer, right, we have to give one application called user interface application. Okay, let me put that here. User interface. That is like a that is the face for your application. So that is the face for your application, which is going to internally work with all these microservices. Okay, which is going to work with all these microservices like this. Okay, so it is going to interact. This is the application that is going to interact with all your applications internally. Okay, like this. So it is going to interact with all these. Okay, not only one, but I can't put everything, all those arrows here, but it is going to work with all those. It is going to be the one which is dealing with all these microservices. Okay, that is the one which is going to interact with all these microservices like this. The arrows will make it too clumsy, but you get the point. Okay, so this is going to work with all those microservices internally. This is the user interface. Okay, so this is how we are delivering our applications in today's world. Okay, in today's world, okay, we are delivering our applications like this. Okay, we'll have one user interface and multiple backend microservices which are going to serve, okay, the purpose of, so they are going to be delivered as independent applications. Okay, so each feature is a different application here. See, if you see, this is one feature, this is another feature, this is another feature, this is another feature. All those features are delivered as individual applications, and combinedly, okay, they are going to be visualized using one user interface here, okay, so that, okay, the customer will not have should see the difference. Customer should not see anything like microservice. For customer, it's one website, that's it. But internally, it is going to work with multiple services. Okay, this is the microservices architecture that is getting used everywhere now. Okay, whatever that you are using in today's world is kindly make, even Netflix, everything, Netflix, Amazon, Walmart, Flipkart, anything. Okay, anything for that matter is using microservices architecture. And what is the advantage now with this microservices architecture? Come, let's, okay, deliver this product. Okay, so now we are using microservices architecture. So now we are going to deal each one as an independent feature, right? Independent application now. Each feature is dealt as an independent application. So now what is the advantage with that approach? So now we can work on requirements for smaller piece. Okay, instead of working on the requirements for all the features, first we are going to work on, okay, requirements for health. Okay, so it's going to be smaller effort compared to compared to working on all the features at one go. Okay, so now we are working on health. Okay, let's say we finished requirements in 2 weeks, then design in 2 3 weeks, then we are working on the implementation, let's say 2 months. Okay, even then, okay, and testing maybe 2 weeks. Okay, overall effort will not go beyond 2 quarters. Okay, 2 quarters, let's say we finished by quarter 2. Okay, health, then payments by quarter 3. Okay, but the advantage here is every feature that is we are delivering, we are going to make revenue. Okay, because we are delivering these applications to the market, and we are, okay, we are delivering health related products and payments we are supporting, and then we are making some money here. Okay, like this we can deliver products deliver features independently to the market, and we can make money immediately. So we need not wait for 1 year to make money. If you can see here, within quarter 3 we are making some money. May not be the money that we have targeted with all the features. Maybe if you add more features, more money will be coming. Okay, but okay, we are, okay, delivering small value and we are getting some revenue, small revenue. So this is the approach that has given, okay, very good results for all the companies. So every company started, okay, using this approach where we follow agile methodologies. We are delivering small value, okay, in an iterative fashion. Okay, what agile is suggesting, to deliver that value iteratively and continuously. Okay, deliver value iteratively and continuously. So this is what, okay, this is what we are, okay, achieving with this approach. We are delivering value, we are doing it, okay, iteratively. And to do this delivery, we need DevOps. Okay, DevOps means, okay, they are, okay, DevOps will be using multiple tools, okay, and to deliver value continuously. Okay, the automations, we'll talk about all the features of DevOps that are making us, enabling us to do this continuous delivery of value to our customers. Okay, so that is the engine that is helping us to do this theoretical. What theoretically, this is what we are saying, delivering value is going to give a lot of revenue. That's what we are saying here. But to deliver this, we need to have some tools and automations. Okay, to deliver this continuously, we need to do something. Okay, what is that? That is the DevOps job actually. DevOps is what is going to achieve this continuous delivery of value to our customers. Okay, so that is what we are going to learn. Okay, from now on. Okay, so this is about the monolith versus, okay, microservices based architecture. So now coming to the problem that we discussed before. Okay, let's say if there is any problem with one of the services, let's say in this approach also problems can happen, right? So, but it is very much, okay, concentrated to one particular application. It's not affecting the entire delivery of the products, all the features. It is not going to impact. If there is any problem with one of the feature, okay, we are going to rework on that particular feature, which is going to be smaller effort again. Okay, which is going to be a smaller effort again, and we are going to deliver value to the customer again. okay, immediately we can deliver because it's a smaller value, smaller issue that we have to fix when compared to the previous one where we have to redeliver the whole thing in a waterfall approach. Like first we have to do the design for everything. Here it is not like that. Okay, so it is like a smaller version that we have to change. Rest all they are not affected. Let's say other features are not affected. Okay, only the features, okay, that has the problem will get affected. So that is the advantage with this approach. So even problems, even if they're existing, they're localized now to a smaller set, localized to a smaller set here. That is the advantage here. Okay. Okay. So any questions here before we move on to the presentation again? Okay, so in today's world, with the microservices architecture, our DevOps engineer's job is to take these features, okay, take these features and deliver them to the, okay, cloud, okay, deliver them to the cloud so that your customers can use it. And we want to do this continuously in an iterative fashion, okay, as and when the features are getting created, immediately we want to deliver them once they are tested, okay, we want to deliver them to the market, we want to deliver them to the market. So this is, okay, what DevOps teams are doing, this is what DevOps teams are doing. Okay, just a minute. Yeah, Swapnil, just a minute. Let's just a minute. I can't hear you, Swapnil, by the way. It's very low. Maybe you have to remove your headset or something like that. Very, very low. I can't hear anything from your side. Okay, while you are trying to figure out that problem, okay, with the mic, okay, so it's a philosophy, okay, the DevOps, okay, it's not only, okay, it's a complete shift of, okay, the way, the method, the practices, tools, everything. Okay, it's not one thing that got introduced with DevOps. Okay, it's a is a set of practices, tools, philosophy, okay, that integrates software development and IT operations to enhance collaboration between development team and operations team. Okay, we'll discuss all those things little later, but so it's not one thing that defines DevOps. Okay, it's multiple things. Okay, it's tools we need to know, mainly tools, practices, and the philosophy of working together with development teams. Operations team and development teams are going to work together very closely. Okay. Yeah, go ahead, Swapnil. Can you speak? Try to speak again. Yeah. Very, very low voice. Try to fix that, please, and you can ask later. Once you think it is fixed, then you can ask later. Okay. Okay, let's move on. Okay, so now we know the issues, okay, with the older approach. Okay, these are old ways of working in traditional world. Working like this waterfall is very old. We don't want to work on all these features, okay, at one go. We want to work in an iterative fashion using agile and agile methodologies and DevOps tools and DevOps methodologies and principles we want to use along with agile to deliver value continuously to our customers. And these are the new ways of working, okay, and that is become very successful, that has begin that is giving very good results to all the companies actually. So that this has become very popular in today's world. Okay, and challenges with the traditional approach, we saw that it's a rigid and sequential process, as we can see. Okay, and then it's there is no customer involvement at all here. Okay, because we are taking almost 1.5 years to deliver a product. During this time we don't involve customers. There is no continuous feedback that we are getting from the customers, whereas in the microservices world, whenever we finish one feature, we go to the market, we get it tested by the customer, and we give that feedback to the, okay, team, again to the business team or to our marketing team. We get feedback, continuous feedback, whenever we are delivering value to customers in our microservices world. Okay, so as I told you before, late discovery of issues, and it's a long feedback loop because it takes a lot of time to deliver value to our customers in the traditional approach, and very limited flexibility, and it's not adaptable at all because we are we are starting with some set of features, and we are not able to fine tune those things in the process of delivering them. Okay, but whereas in the microservices world, let's say we are okay working like this. Okay, microservices world, we start working on health. Okay, we start working on health in quarter 2 and finish in quarter 2. Then while we are working on payments, okay, the customers are using this health, so we get some feedback from our customers and we can fix those issues maybe in quarter 3. Let's say, for example, I'll put it this way. Okay, um, so this way feedback was given, and we understand the issues that are happening in the, okay, issues from prod for production. When I say prod production for health feature, like this. Okay, so like this. So once it is delivered to the production, okay, we can work on issues that are coming from, okay, production. Similarly, every feature when we deliver, okay, immediately after delivery, we called it as hypercare in some companies, we call it as production support in some companies. Okay, depends upon which company you're working for, they have different terminology. Okay, different terminology. So like this, we can work on some production support or hypercare. Production support or hypercare, something like this, where we're going to work on some of the issues that are happening in production, like this. Okay, so what we're in this process, we get feedback, right? Because there are issues happening. Okay, we get feedback from customers, so we are correcting ourselves, okay, for our future journey. Okay, let's say by the time we come to the groceries feature, we would have known what are the common issues that can happen in production. Okay, what are the common issues that are happening that we have missed during our initial health and payments features? We would have missed something. That's what we are going to, okay, correct ourselves. So there is a scope for correction here. Okay, so there is a scope for correction here. We can adapt to some of these issues that are happening in production and make sure that they are not repeated for our future deliverables like groceries or, okay, electronics. So that's what we can assure. Okay, and in the previous traditional approach, every team is independently working, as you can see from my diagram before here. Okay, business team is working on requirements, and the domain teams are working on this, and operations team is working on the below features here. Okay, that is independently working. Okay, so they are working independently, but in the, okay, agile world and with DevOps principles, which we are going to see soon, we have to work together to deliver value to the customer in a faster manner, and we are going to discuss those topics. Okay, and another problem with the traditional approach is delayed delivery. As we saw, each time we want to create a new feature, it is taking 2 years of time, whereas in the microservices world, we can deliver value to our customers within 1 quarter or maximum 2 quarters. We can, or maximum 3 quarters, we can deliver value to our customers. Okay, and then start making revenue. Okay, this is a high level monolith versus microservices architecture that we have discussed before. Monolith is left hand side here, where everything is combined into single application. Okay, all the features are delivered as single application. Okay, for example, you can imagine this as a microservice. Okay, in 2000, before 2010s, or even today, I think Microsoft is going to provide you. Okay, is okay when you purchase a Microsoft Office suite, you get everything together. Okay, especially before 2015 period, you have to purchase a compact disk, CD. Okay, compact disk where all these features are available in one compact CD, and then we are going to install that using compact CD-ROM. Okay, CD we used to use, and we used to install these products in our laptops. Okay, so that means it is a single package, okay, single application package, and we used to install it. Let's say, for example, there is a problem with PowerPoint in Microsoft release product. So we have to wait for the next release, okay? And let's say they have released in 2010 a product and there is a problem. We have to wait at least 1 to 2 years to get the new version of Microsoft Suite with all the issues fixed. Okay, it's not possible to get them in between. Okay, in today's world, what will happen? Let's say there is an problem with the application. Immediately within few days, we'll get an update saying, okay, there is a problem that we have fixed. Apologies for the issues that we have seen, and you'll get a fix soon. Okay, so that is microservices architecture. You can imagine, where if there is any problem with any of these products or any of the features, then immediately we can work on them independently. No need to wait for years and years. Okay, and there are multiple reasons why we are able to do that in today's world. In today's world, we have cloud. Okay, in today's world, we have cloud, we have agile methodologies, we have DevOps. Okay, all these combined together, they are delivering the value quickly to the customer. Okay, previously we don't have cloud. Before 2010s, we don't have cloud, so they have to deliver these features, okay, via compact disk. They have to ship these devices to us. Okay, but in today's world, there is no such thing. We like compact disk. Okay, we don't need compact disk. We can install everything from our app stores, or we can use them from our browsers. Okay, so no need to wait for that long periods. So that is the advantage we have. Okay, Swapnil was asking a question. What is the major cost associated with shift from monolith to microservices architecture? Because isn't it like exposing each application as service in microservices architecture? Okay, so the cost involved is, first of all, okay, we have to compare the cost versus the advantages and future maintainability perspective. So the major cost you can see directly here. Okay, so previously, okay, the cost, we are holding all our team members. Okay, for example, this is the period, right, in which we are delivering a project. So if you see in this monolith architecture, this is the period. For example, 2 years we are waiting to deliver value and get the fruits or get the revenue for our product. 2 years. That means all the teams have to be paid for 2 years to get the real outcome. Okay, real outcome. We have to get the revenue. We have to wait for 2 years, and we have to invest 2 years of, we have to pay for our employees, we have to pay 2 years of salaries, okay, to get this money here. Okay, so now with microservices architecture, we can go incrementally. That means we need not hire everybody on day one. Okay, we need not hire everybody on day one. We can, let's say, start with 10 people, 20 people. Okay, we can start with 20 members team, and then we can deliver. Maybe business team will have 4 or 5 members. Okay, the delivery team or the domain team will have 20 members, testing team 3 or 4 members, and then DevOps team members maybe 3 or 4 members. Okay, so that is the scale we can start with if we are going with microservices based architecture. But whereas here, you need everybody on day one. Okay, day one you need everybody, because you need to capture requirements, then immediately design. Maybe at least for 2 quarters we don't need the complete team, but after quarter 3, by the time we come to quarter 3, you need majority of the team members, because everything we are working at the same time. Health requires, let's say, 20 team members, payments 20 team members, groceries 20 team members, electronics 20 team members. Like that, it will become when compared to microservices versus monolith, it is at least 4 times of what we have. Okay, with microservices based architecture, that many team members, we have to maintain them for 2 years. Okay, So that's a lot of cost involved to manage that much, that big teams actually. And that is one cost, okay? So now another cost is, okay, the corrections. Let's say something wrong happened and we have to correct our design. Then again, we have to wait. We have to keep this whole team members waiting for another at least 2 quarters or 3 quarters. Okay. So that means there are some problems here. We have to fix that problem and we have to move towards microservices based architecture. There is a cost involved for changing from monolith to microservices based architecture. There is a cost involved, and companies are ready to take that, okay, cost into account, considering the advantages that are available with the microservices based architecture. So there is a cost involved. Okay, everybody, okay, every company, if they have to change from monolith to microservice based architecture, there is a cost involved. Okay, another cost is, okay, cloud. Okay, cloud costs are involved here. Okay, we have to definitely microservices based architecture. If you want to deliver, cloud is required. Okay, so that is another problem, or another cost that is involved here. Okay, so slowly they have to transition their applications from microservices, sorry, from monolith to microservice. They have to take out this feature, for example, delete it from here and create that as a feature here, right? Create that as a separate application here. So that is a cost involved here again. So let's say I've taken out health from monolith and I created a microservice architecture. Next one will be remove groceries from here and make it as a microservice architecture. Remove payments from here and make payments as a microservice or small application here. Electronics, remove from here and then make it as a separate application. So there is a cost involved like this as well. Okay. So, and coming to the exposing this application in cloud. So as I told you, cloud cost is involved. Okay. Cloud cost is involved. But the advantage is, okay, with the cloud, we don't see cloud when compared to the resources, maintaining multiple resources in your company to do means to overcome the issues that are happening with monolith. Cost of cloud is comparatively less. The resource cost is more when compared to the cloud cost. Our cloud cost is less when compared to the engineers cost that we spend on engineers is the amount of cost that we spend on engineers is very high when compared to the sorry, when compared to the cost of the cloud. Okay, so that is the main difference, Swapnil. Okay, all good. So let's move on. Okay, now DevOps foundation. Okay, so what is DevOps and why we are learning DevOps? Okay, what are the different models of ways of working of DevOps? We'll try to understand. But before that, we'll take 5 minutes break. Any questions before we go for a break? It's going to be another 1.5 hour session today. So better to take one. This is a first class, so better to take 5 minutes break before going for break. Any questions you have? Okay, all good then. Let me start a timer. Okay, we'll see you in 5 minutes. Okay, so I'll keep it. I'll stop. Pause the recording so that recording you can skip this. Okay, pause recording. Just a minute. Before going for the break, we were understanding about the differences between monolith and, okay, microservices based architecture. Okay, and we'll continue with the, so that knowledge is very important for continuing with our next, okay, whatever, to understand DevOps better, we need to understand the architecture difference. Okay, then we are going to see how this is helping us deliver value. Ultimate goal is to deliver value, okay, to our customer. So understanding the shortcomings of our previous architecture and the latest architectures are important. That's why we learned that. Okay, just a minute. I'm trying to, yeah, no, Bluetooth. Yeah, all good. Okay, let's understand what is DevOps. Okay, so first of all, okay, so DevOps, when there is a person called Donovan Brown who was working for Microsoft. Okay, during 2007 2008 period. Okay, he coined this word called DevOps. Okay, and the link is also provided here. You can just go through it whenever you are free to understand a bit more of why how this got created first of all. Okay, so it's not a product. Okay, definitely DevOps is not a product. Okay, so that is the first thing. DevOps, as I told you, okay, I will give you different definition later, but okay, the when it was created, this is the main idea. Okay, this is what he termed it as. Okay, it's a union of people, process, and products to enable continuous delivery of value to our customers. So this is very key. Okay, so it's a union of or amalgamation of people, process, and products. Okay, and uh, majority of the okay, in this, what is the main out of these three? What is the main one? I would say is the products. Currently in today's market, maybe when he coined this term, okay, so the collaboration is main very important, because at that time collaboration was not at all there, and at that time process was not at all okay followed. Okay, every company used to follow different process, and okay, at that time products were also not there. Okay, but in today's world, okay, agile is okay, people and process. Agile majorly dealt by agile. Okay, it's already everybody used to using agile methodologies, scrum framework, other stuff. So this is okay already okay well understood, and every company is already doing great in this area. Okay, so now in today's world, okay, this has become the so this has become the main activity for our DevOps engineers. Okay, so that is the main difference. When he coined this term, okay, when he created this statement, okay, when he announced this statement in a meeting, okay, so at the time there was no collaboration, there was no process, and there were no products, DevOps related products. Okay, but in today's world, okay, we have these practices and people working together and everything already, but okay, the more focus is on products. Okay, more focus is on products, and in our course also we concentrate on mainly on these things. Okay, and we take this for granted. When we are going through this course, we take this for granted, and ultimate goal is same at that point also, and today's world also, the goal is same. The goal is to enable continuous delivery of value to our end users. This did not change at all. Okay, this did not change, but okay, this changed. Okay, bit this changed drastically, I would say, not a bit but drastically, because today's world, people and process is already very well understood, and every company is doing great in that area. But DevOps wise, okay, we are going to mainly concentrate on different products for different requirements to deliver continuous value to our customers. That's what you keep in mind. Rest all definitions, okay, no need to worry. Okay, rest all definitions, no need to worry. Okay, so that is the main thing that we'll be concentrating on. Just a minute. Went 1 minute. Okay, so this is what we have to concentrate on. Okay, so now let's understand a bit more in this area. Okay, okay, so as I told you, okay, it's practices, okay, people practices, and okay, tools. Okay, you can say people practices and products, or people practices and tools as well. So that is what we are going to concentrate on now. Now on, okay, mainly about products. Okay, so let's move on. Okay. Okay. So the actual term DevOps, when it was coined, it's about development and operations. Okay. Development and operations team has to, yeah, recording has started. Kumar, yes, it is continuing. Yeah, recording is being done. Yeah. So DevOps is about development and operations. Okay, development. It is, see, this is the old definition as I told you. Okay, development and operations team were not working together at that time. Okay, so it's more about collaboration, people, process, and okay, products. Okay, but today's world, DevOps, okay, because we are already working together. Okay, development team and operations working together. Okay, so it's more focus is on tools. That's what I was telling. But the whole definition when it was created, it was about people, process, and okay, products. So it's about bringing people together and reduce the knowledge handover times. Okay, because if you are bringing together the teams, okay, that means they are already discussing. Okay, every day. Okay, using the process, agile process. What is agile methodology says? Okay, there should be some regular activities, Scrum activity. For example, if you take Scrum, every day we have okay daily stand up where everybody provides their update and they highlight if there are any dependencies or any problems. So this happens every day in okay Scrum framework. Okay, for example. Okay, so that means every day we are interacting development. Let's say in this picture, okay, this is your development team and this is your operations team. They're working together as a team. Okay, and they are going to deliver. Okay, every day they are going to work together and they're going to deliver value to the customers. We'll see how the value is delivered, but they're going to work together. That means the amount of okay they are going to be aware of what is happening in DevOps area. Developers are aware of what is happening in DevOps area, and DevOps is aware of what is happening in the development area. So they are working together. Okay, and the another goal of the goals are to work together so that the knowledge handover times are reduced. And another goal is to automate anything that is done manually. Okay, this is about the tooling part. Okay, so the tool focus I told you before, the main goal of to use the tools is to make everything automatic and there should be no manual intervention and everything should be automated. That is the main goal. So these goals were not clearly defined when the definition was created. Okay, but these are eventually these things got updated actually. Okay, in the so DevOps, the main intention is to automate anything that is done manually. Okay, and ensure this happens continuously to deliver value to our customers. Okay, this is another goal, to want to deliver continuously. That is anyway defined in the initial definition, to deliver value continuously to our customers. That is the main idea. So DevOps is more of a development culture that focusing on producing quality product as efficiently as possible. And this is possible, okay, with automation. It helps automate the whole development process and hence increase the efficiency and decrease the cost. Okay, so DevOps goals. Okay, these are the goals when we are saying, whenever we are doing something, we always have to align with these goals. Okay, one is okay to work together to reduce the knowledge handover times, to automate everything that is done manually, and we want to deliver this continuously. Okay, and we want to okay give make it the whole process as efficient as possible and reduce the cost. Okay, as efficient as possible and to reduce the cost. Okay, so these are the, and we have to ensure that the product quality is as efficient as possible, product quality. So these are the main goals of DevOps. Okay, let me highlight them here so that okay you can focus on them when you are also attending some interviews. Okay, so let me highlight here itself. So bringing people together and reduce knowledge handout times. Let me make it bold and make it with a different okay color so that you can focus on that. Okay, so to automate anything that is done manually. Okay, so that is another thing, and ensure this happens in a continuous cycle to deliver continuous value. Okay, this is another thing. Then okay, producing quality product as efficient as possible. Okay, this is another key goal. And we have to increase efficiency and decrease the cost. So these are the areas that we have to focus as a DevOps engineer. Okay, these are the goals of DevOps. Now let's move on. Okay, so what are the different personas in a typical Agile DevOps team? Okay, Agile DevOps team. Now we have to understand the team structure also. So DevOps teams, okay, this is how a typical team looks like in today's world. Okay, so the business team is going to provide the requirements, then it is going to be owned by a product owner to deliver value to the customer, and using the help of these team members here, okay, the product owner is going to, okay, promise to business saying, I'm going to deliver with if I am given a team like this. Okay, so this team structures, different team structures are there. Okay, we'll discuss that also. Okay, but this is the most common and successful team structure. Okay, that is that we'll see in any company, where there is a scrum master following all the agile practices and methodologies, developer delivering the products, and quality assurance team delivering the testing and finding the bugs, and DevOps engineers who are, okay, acting as a backbone for our team, and they are making sure the value, okay, they are making sure all the goals here, for example, bringing people together, reduce knowledge and handover times, automation, continuous delivery of value, product quality, efficiency, all those aspects will tick one by one. Okay, all those goals will tick one by one. Okay, so those are the aspects our DevOps engineers are going to take care, and they are going to be acting like a backbone for any project or for any company for that matter. Okay, so we'll see how, okay, how they are doing this, we'll see. And this is, okay, Scrum Master centric view. Okay, that's what we have shown here, where Scrum Master is talking to DevOps engineers, developers, and quality assurance teams. But if you see, okay, so if you see, this is how Scrum Master is going to interact with, okay, from Scrum Master point of view, Scrum Master is going to interact with multiple stakeholders in our project. Similarly, DevOps engineers are going to have this kind of an interaction. So you don't know as of today how DevOps engineers are going to, why DevOps engineers are going to interact with or are going to have an interaction with quality assurance team. We'll see that later. Okay. So DevOps engineers teams are going to work together with developers, because developers and DevOps teams have to work together to deliver value, and to deliver value to the customers continuously. So for example, let's say a developer is developing health related, in our example, retail, in our example of retail application, developers are developing health related products, payments, then retail, then groceries, then electronics, right? So they have to be clear on what are the requirements with respect to the infrastructure. Okay, so DevOps and developers have to work together on different aspects, which we are going to discuss later. Okay, in our next few classes, we are going to discuss how DevOps and developers are also going to work together. Okay, there are so many classes with respect to that. Okay, then DevOps engineers have to work with our product owners to see what is the, okay, number of, okay, number of customers that we are targeting, so that the right infrastructure can be created for the customers. Okay, for delivering these features, we need the right, okay, right cloud environment, right infrastructure. Okay, so we need to be interacting with product owners. Similarly, okay, for anything related to process and delivering delivery deliverables, we normally interact with Scrum Master regularly. Okay, then Scrum Master can interact with product owner, or product owner can be joining our, okay, some of these Scrum ceremonies, like, okay, for prioritization or for feedback or anything like that. Okay, so DevOps engineers are going to be acting like a backbone for any company. So that's why we have so many DevOps opportunities outside, and some of them are getting automated, but still DevOps engineers will be required, because there are so many areas to cover. So as you can see, okay, if you see here, DevOps engineers majorly work on build, continuous integration, deployment, operation, and the feedback also. Okay, so planning is mainly done by our business teams, and we are going to take that work based on that plan. So these are the areas that our DevOps engineers are going to work in every iteration, and it's going to happen continuously, as you can see. That's why it is an infinite symbol here. It's going to happen continuously. Okay, every iteration we are going to repeat this process. Okay, every iteration we are going to repeat this process. Okay, so DevOps engineers responsible for, okay, so this you can ignore. So anyway, we discussed this one. Okay, so the goal of DevOps, okay, so in this particular SDLC process where we are starting with planning, then we are building, then we are integrating continuously the work done by our development teams, then we are deploying this work to our cloud environments, then we are managing these applications in our cloud environment, then we are getting continuous feedback from our, okay, systems that are, okay, deployed, or the applications that are deployed to production, and then taking that feedback and planning for the next activity. So in this process, okay, and this is the continuous process. Okay, in this process there are different tools that are involved, as you can see. Okay, the tools like Jira, Confluence, Azure DevOps boards. Okay, and in this, okay, for the planning, we are going to learn specifically, okay, because we are learning Azure DevOps tools. Okay, we are going to learn about Azure DevOps boards because that is involved as part of Azure DevOps product. We are going to learn how to use this, and I hope you already know how to use Jira or Confluence. Okay, the Jira is similar to Azure DevOps boards. Okay, these two are similar, and Confluence is for documentation purpose. And these two products are provided by a company called Atlassian. Okay, so similarly, the similar product is provided by Azure DevOps also, and we are going to learn that in our classes. Okay. Next one is the build phase, where our majority of time we are going to spend on build, continuous integration, and deployment in our next classes. Okay, so where we are going to learn tools like Gradle, Maven, Azure CI, Jenkins. Okay, we are going to learn about Kubernetes here, and we are going to learn about, okay, deployment. We are going to learn about Jenkins, Docker, Azure CD, all of them. Okay, Chef is not there. Ansible, we have some recorded sessions. You can get that knowledge from that. Okay, so in this, okay, dashboards, we don't have feedback classes, okay, because that is coming in the last, and that is mainly for operations teams to get a view of what is happening. So we are not covering this one, but rest all are covered. Okay, rest all are covered as per our, okay, as per our plan. So these are the tools that are involved. Okay, so now coming to the DevOps culture. Okay, nowadays you hear a term called shift left culture. Okay, not only for DevOps, everything shift left. Okay, so shift left means, okay, I will give an example here. Okay, so let's say, okay, let's say, okay, for example, in traditional world, I told you already, like a development team is going to develop something. They're going to, okay, test the applications in some area. Then finally, before pushing the applications to production, operations team will be involved. Okay, in the traditional approach, what is happening? Okay, we work on, okay, business requirements. Okay, let's say I'll put business requirements. Then we work on development, and then we test it. Then we are going to deliver that. Okay, we are going to give it to our operations team to deploy to production, let's say. Okay, so that's where our traditionally our support team members are working. Okay, are involved. Okay, so that is the traditional approach. But in the shift left, what is happening is, okay, this is what is happening, shift left. Okay, so everything is getting shifted left. That means DevOps teams are involved very early in the software development lifecycle. That means DevOps team and development team and every member is going to work together. Okay, from very early stages of the, okay, from very early stages of the software development lifecycle. Okay, So the advantage we have already seen, okay, like one advantage is the amount of, okay, the amount of, so this one knowledge handover times are reduced. If you bring development team and operations team very early together, then the amount of knowledge handover, okay, the time it takes for handover will reduce. That is a good saving, okay. And also all these issues will be highlighted very early in the software development life cycle. So that is another advantage actually. Shift left, the advantage is everything is going to get identified very early. We don't need to identify them in the production or when we give it to the customer. Before even we give it to the customer, what we want to do is we want to try everything in our, okay, development environment is should be like our production environment. That is the idea here. Shift left means, okay, the thinking is treat development environment like a production environment. Whatever the development team is delivering during the development, that should be treated almost same as production. And we have to try all the things that we normally try in production in development environment itself. Involve your DevOps team during the development itself. Involve your testing team during the development itself. Involve your security team in the development team during the development itself. That is what is DevSecOps. Okay, DevSecOps. Okay, shift left. Everything is shifted left now. Okay, previously what used to happen is, okay, let me put that also here. So let me put one more diagram here for DevSecOps as well, because somebody has raised that. Okay, I'll just copy this slide and then put one more slide for DevSecOps to give a view of what's happening in today's world. Okay, I'll just copy this. Okay, so now what is happening is, okay, I will add some content later for okay, shift left DevOps is another thing. Shift left, recent trend called shift left, okay, promotes self-service thinking. That means everything, okay, will be treated like, so your development environment is treated like, okay, development environment is treated in treated almost same as prod environment. Okay, that is the thinking. Okay, that is the shift left thinking. So don't wait until production. Okay, make your development environment as similar. Okay, okay, make development environment as similar as prod environment. That is the main idea with shift left thinking. Okay, shift left thinking is promoting this. Okay, promoting this. Shift left thinking is promoting this, promoting okay, promoting this thinking of, okay, treat your production environment, okay, treat your development environment same, almost same as production environment. So that what is the advantage with that? We are going to identify issues. Okay, so let me remove this anyway, these are repeated there, so in the previous slide. So like this. Okay, so advantages, let's understand the advantages now, and also I'll cover the DevSecOps part. Okay, so advantages are identify issues that might happen, that can happen in production early. Okay, that is one advantage. Try different security patterns in dev environment itself. Don't wait for production. Okay, okay, try, I will say enforce. Okay, instead of try, enforce different security patterns in dev environment itself. And okay, and mature these. Okay, mature these these harden harden the harden the pattern. So like this, okay, these are the advantages. So, and collaboration, what do you call, there's one more actually. So let's say, for example, in production, you can have different, okay, disaster recovery scenarios. Okay, for example, disaster management can be replicated, can be replicated in replicated early and early. That's what we can say. Okay, disaster management can be replicated early. So in production, you can have disasters. Okay, you can have disasters like suddenly some systems can crash. Okay, so you can replicate those kind of scenarios. Okay, um, disaster or chaos management can be replicated. There is something called as chaos management can be replicated early. So basically, we are trying to replicate everything very early, shift left. Okay, instead of waiting for something to happen in production, we are trying to anticipate those things. Okay, anticipate. Okay, anticipation of. Okay, anticipation of fraud-like scenarios in dev environment itself. Okay, so these are the advantages that we have with shift left thinking. Okay, with shift left thinking, advantages of shift left thinking. Okay, now coming to the security aspect. Okay, so DevSecOps. Okay, when we say DevSecOps, okay, so integrate security patterns. Okay, so I'll put one more slide for that. DevSecOps culture. Okay, what is this? Integration of all the security paradigms, okay, into the systems. Okay, integration of all the security points into the systems and automate them. So this is what DevSecOps culture talks about. Okay, so again, okay, shift left. Now here shift left DevSecOps thinking. Okay, let's shift left DevSecOps thinking. DevSecOps thinking. What does this mean? Okay, again, same thing. No, for example, okay, same thing. Make development environment as similar as production environment in terms of security. That's it. Why? What are the examples here? Okay, so what we do here? Okay, in terms of security means what? Okay, we replicate scenarios like eavesdropping, like somebody listening to whatever we are trying to do in production. For example, you as a Facebook customer, you're doing something. Okay, you are communicating with your friend, sharing some photos. Okay, and somebody trying to eavesdrop into your communication somewhere using some of the. Let's say you have used some public computer somewhere. Okay, somebody still okay trying to use your systems and credentials and trying to use those credentials to get access to your bank account, for example. Okay, okay, so those kind of scenarios you have to try to replicate, okay, in your non-prod environment or dev environments itself. That's the idea here. Replicate scenarios like eavesdropping, using identities in social media. Okay, so these are the things that we try to replicate. Okay, and as a DevOps engineer, we are going to help our, okay, okay, let me delete this, some of them so that I can see the content here. Yeah, so what we're trying to do here during the development phase itself, okay, we are going to integrate the security patterns. Okay, that is what DevSecOps culture is. Security patterns integration into the into using different tools like for security. It's all together a different set of tools will be used. Okay, from for example, integration of Splunk into the system. Advantage of shift left. I'll put something shift left DevOps thinking tools used for DevSecOps. One such tool is Splunk. Splunk for monitoring of logs and identifying, monitoring of logs and identifying anomalies. And this can be integrated, very early into your development environment so that you can try to identify those very early whenever it is happening. We can identify. There are some attacks like DDoS attacks. So DDoS, I forgot the full form. 1 minute, I will just try to Google it quickly. DDoS attack. DDoS means distributed denial of service attack. So let me bring that up here. So something like this. So DDoS attack means we are some systems, they are going to actually attack our systems with lot of systems from external world. So they are going to bombard our server with overwhelming requests. That is the main thing that happens in DDoS. So let's say, for example, our systems can support 1,000 customers only at a time, but they bombard our systems with 2,000 requests. They are going to use multiple zombie machines to attack our systems, to make sure, let's say, for example, during the sale period, Christmas sale period, or during the Black Friday period, or during the different sale periods, Christmas, those kind of events, if they make sure that our systems are down, and they are not able to make our they are not able to, if they are not available for our customers, that means we are going to lose revenue and our competitors will get revenue. So somebody can do for some upcoming companies can use these kind of cheap techniques as well, to get more customers into their area, or to grab more customers. So these kind of things can happen, so we have to avoid these kind of things. This comes under security, DevSecOps. So DDoS attacks should be identified early using cloud. So every cloud will provide some notifications. For example, AWS will have Cloud Watch. We just need to listen to them, that's it. What DevOps engineers will do here, we are going to monitor, that's it. We are going to use these, subscribe to these notifications, that's it. So this is DevSecOps culture. There is nothing different from DevOps culture here. It's all about different tools and different services we are using to automate this stuff. So we need not separate that as a different technology altogether. It's the same thing that we do to improve our systems security. Security, or what do you call, I'm not getting the term. Security, like we can say security paradigm, we can say, or I'm not getting the right term, but you can say security paradigm. To improve the security overview of our company's systems, then we have to just integrate some extra systems into our system and make sure these are done very early in the development phase. So we don't want to wait for production and then do these things. We have to try these things. We have to have shift left DevSecOps, so that we want to try all these things even very early in our development phase. And every company is doing this nowadays with all these cyber security issues and all. So to avoid cyber security attacks, I would say that to avoid cyber security attacks. Okay. So this is what, okay, DevSecOps culture is about. Okay. And we know the benefits already. Okay. Currently, we understood what are the benefits. We don't know yet. We did not see it with our eyes yet, but theoretically, based on whatever I have explained, so we understood that there are some advantages like, okay, development frequency, faster time to market. We'll see how it is happening later. And recovery time can be faster because we are automating everything. So recovery time will be faster. Okay. So that is what we are trying to achieve. And we want to improve our systems, make them efficient, and okay, always okay, whenever every iteration we want to take the feedback and we want to improve and we want to, okay, make less number of failures. Okay, we want to continuously improve ourselves and make them efficient. That is the thing that we are trying to achieve using DevOps, and DevOps can do all these things. So we'll see how. Okay, what we are doing here, we are explaining, but how we are doing, we will explain with the hands-on tools. Okay, with the tools, we'll explain that. Okay, so conclusion. Okay, so previously, this is how, okay, it used to be without DevOps. Okay, so we are trying to motivate ourselves to learn DevOps, and we are trying to understand what were the challenges and what are the advantages now. Okay, how we have overcome those issues that were happening before with Agile and DevOps. Okay, so this is the legacy way of working where this is business team. This is the domain team where they're doing the development, and previously operations team used to be there, and every team is working in silos here. That means they are working independently here. In the traditional world, this is before 2010. Okay, this is before 2010, but now the picture is, okay, Agile is fixing this issue here. So previously we used to have waterfall method, but with Agile, we are having iterative deployments, and everything, like we are going to work iteratively. Okay, Agile is fixing the process, people and process area. And okay, this is the issue that got fixed with Agile. Okay, now the other area. Okay, so to deliver continuous value to the customer is fixed in this, okay, by DevOps. Okay, so now there are no walls between development teams and operations team. That is fixed with DevOps. Okay, so this is how, okay, we are E2E meaning end to end. Okay, end to end. So this is how end to end works. That's what we are saying here, end to end. Okay, yeah. So now to do this, okay, we need different tools. Okay, you better take a screenshot of this, or okay, when I give the material, please take a printout of this to understand the uh, landscape of the tools that are used in DevOps. Okay, it is better to have a picture of this if at all you are planning to be in this world for next few years. It is better to take the picture of this, put it on your desktop. Okay, so this will give you a motivation to learn different tools for different, and you know the mapping of each of these tools for uh, different areas. For example, okay, for source code management, okay, we use Git and Azure repos. So we are going to learn these two tools. Okay, 1 and 2 we are going to learn. Okay, then so this is falling under source code management, and it will also fall under code checkout and build. Okay, so we do code checkout and build, and this falls under a high level category called source code management. Okay, and next set is build tools. Okay, so these are the different build tools that we are going to explore in our upcoming classes. Okay, and they are used for, okay, software development SDLC phase, which is unit testing. These build tools, okay, this is the SDLC phases. Okay, you can think of these are SDLC phases. Okay, I will put that explicitly there so that you don't get confused what is the top one and what is the bottom one. Okay, I will just put that quickly. Okay, SDLC phases, I would say. Okay, SDLC phases. Okay, software development lifecycle phases. Okay, so we are going to learn build tools like Maven, Gradle, and NPM. Then we are going to learn about, okay, so I'll just put once again, this is one area we are going to cover all. Okay, this is another area we are going to cover all. Okay, we are going to cover these phases in SDLC. Quality control we are going to do. We are going to do it with Sonar Cube only. We don't cover this coverity. So it is one competitor tools actually. We are going to cover one of those tools. Then in the deployment, we are going to cover all of these. Oh, sorry, just a minute. Yeah, we're not going to cover this CI/CD here. Okay, we are going to cover Jenkins and Azure pipelines. Okay, Jenkins and Azure pipelines we are going to cover, and this comes under deployment to test environment and other environments. Okay, so that is the SDLC phase there. Okay, now next one is, okay, testing frameworks. Okay, we are not going to explicitly cover testing frameworks because we are not into testing. Okay, this is not our scope, but in real world projects, okay, the integration of this testing frameworks we'll show you how to do with Maven, Gradle, and NPM. Okay, so that we'll show. So that is already covered in this area. Unit testing area will cover that. Okay, we'll cover that. Okay, so next is packaging and archiving. Okay, so which latest builds. Okay, that is going to be covered later. Okay, so this one we'll going to cover Azure artifacts, and one more is a Docker Hub. Okay, these are the two we are going to cover: Azure artifacts and Docker Hub. We are going to cover next. Okay, we are going to cover, okay, how to deploy our, okay, we are going to cover Kubernetes here. I think I forgot to mention Kubernetes here. We are going to cover Kubernetes here in this area. Kubernetes will be covered, and we are going to try that in our AWS and sorry, in our Azure. Okay, Kubernetes will be covered in our Azure. AWS, we are going to use virtual machines. Google Cloud is not at all there in our scope. Okay, we are only covering some of the features of AWS and Azure. We are going to cover Kubernetes services. And configuration management and deployment tools, we are going to completely cover Terraform here. I will update that to Terraform here. Okay, Terraform we are going to include, and Ansible we are having recording classes. Okay, so fetch is covered, deploy to pre-production is covered. Okay, acceptance testing means it will come under testing again, so we don't cover that. Production deployment we are going to cover. Okay, so these are the areas that we are going to cover in our upcoming classes. Okay, so coming to the questions, theory is asking, how is unit test not included in the test environment, please? I mean, what is the difference? Unit test is in the, so unit test is covered during the software. So during the automation, unit testing can be done with the automated tools itself. So no need to be done in the, okay, I think I have to show some testing scenarios as well. What are the different testings that are, I will show that in the diagram here. I should have some diagrams for testing. Just a minute, I will try to get that CACD. Just a minute. Jenkins. Yeah, here. So manual testing, okay? Manual testing is done after the deployment. So let's say, for example, here, okay? So once the deployment is done to the test environment, after this phase in the software development lifecycle, let's say after this, once we deploy to the test environment, this is where different testings can happen. Okay, manual testing, regression testing, okay, progression testing. So so much testing can be done. And what are the different types of testing? Okay, so if you see here, unit testing is one area. Okay, component testing is another area. Integration testing is another area. So all these things can be done in the testing phase. Okay, we'll see when we cover this continuous integration, continuous deployment. I will show you, okay, how the unit test will be executed automatically. Okay, we'll show you that. Okay, don't worry about that at this point. We'll show you how unit testing can be done. Okay, during the test phase of our. Okay, so you don't know this diagram yet. Okay, so that's why I can't explain that much. But when we come to that phase, anyway, I'm going to cover that. Okay, don't worry about that. So yeah, so we'll see that during that time. Okay, otherwise it will be like too much for today. Okay, yeah. Other than that, what else? Okay, so these are the tools and these are the coverage from our course. Okay, so this is how we are going to progress. Okay, so I will update this diagram to show, yeah, Kubernetes is updated here. I will update, Terraform is also updated here, but I did not put the number of days and other stuff. So what I will do is I'll quickly update this Terraform here. So from day 16 to day 22, it will be, okay, day 16 to 22, it will be Terraform here. So sometimes we go beyond the planned number of days because sometimes we have to cover little extra. So that don't mind, don't worry. It's not strictly within that many number of days we are going to finish it. Okay, but we go beyond sometimes. Okay, so this is about, okay, the introduction to DevOps and why we are learning DevOps. Okay, any questions before we move to the next section of cloud computing? Okay, we are going to cover until this part today. Okay, until we have few more slides to cover. And cloud computing, we are going to cover in the next class, which is on Tuesday again. Okay, so yeah, let's move on then. Okay, so we know what we are going to cover in our training and what are the number of days that we are going to cover. Okay, now coming to the differences between Agile. Okay, so we are saying Agile and DevOps, right? So better to understand what are the differences between Agile and, okay, so they're not comparable, but we are just going to see what are the differences. Okay, okay, so what is Agile? Okay, I know a lot of you are from Agile world, so I don't want to spend much time here. Okay, it's a software development methodology which promotes shorter development life cycle. Okay, instead of working on big feature, on everything, instead of working on everything, we are going to work on smaller chunks. Okay, so that we can improvise ourselves. Okay, while we are delivering the overall product. Okay, we don't work on all the features at the same time. We are going to work on one at a time. Okay, and we are going to incrementally improve ourselves. Okay, so in Agile, if you are using Scrum as a framework, Scrum follows Agile principles. Scrum is one such framework created using Agile principles. If you are following Scrum in your projects, we have something called a sprint. Okay, sprint is nothing but a small iteration where we are going to work on some deliverables. For example, some companies have 2 week sprint and some companies have 4 week sprints. I've seen both. Okay, both kind of Scrum teams. So in one sprint, what we are going to do is we are going to analyze the work that we are going to do. We are going to plan before the sprint starts. We are going to do the design, build, test, and review and launch. Okay, we are going to deliver some value in that particular sprint. Okay, then again we move on to next sprint, which is like after 2 weeks or after 4 weeks. Again in this sprint, we are going to take the feedback from sprint one. That is another one feedback loop. Okay, feedback is what is important for Agile, and in Scrum we have this facility to after every sprint we can take some feedback and analyze that, again plan how to fix that feedback, then do this repetitively. So like this, okay, for example, if you are working on health related product, okay, in our retail example, retail application example, we can start with health as one application here. Okay, then after 2 3 iterations or maybe 10 iterations, let's say health is completed and we are moving to sprint n, let's say sprint number n or sprint number 10. We deliver this health product in last 9 sprints, right? Okay, ninth sprint we delivered our health application to production. Then in 10th sprint we take the feedback that customers are providing or what's happening in the production, we get that feedback, and then in sprint number 10 we are going to fix those issues. Okay, fix those issues, or we take the feedback and try to see how to improve ourselves. So we are getting a feedback, okay, after some time, and then we are improvising ourselves. Okay, so that is what is Agile is helping us with. Okay, benefits, we have transparency because in Agile we can do planning upfront of what we want to deliver and how much cost it is involved, because we have a clear picture of what is involved in delivering a product. And we always have scope for change, because we can every iteration, after every iteration we can get the feedback and we can improvise ourselves, and that means we are improving the quality ultimately. Okay, so these are the benefits of Agile, and previously we have seen the benefits of DevOps as well. Okay, they are different if you see. Okay, if you see the two things, okay, Agile versus DevOps, their motivations are different. So that's what we are going to understand now. Okay, we are going to understand what are the motivations of Agile and what are the motivations of DevOps. Okay, the motivation for both is same. Customer benefit focused. The motivation is same. So both want to deliver as much benefit to customer as possible. Okay, but Agile does not talk about development process improvement. Okay, so see, it talks in theory, but it does not do anything to do this in practice. But whereas DevOps with the automation tools, okay, how DevOps can do this with the automation tools by integrating some tools like SonarQube, okay, by integrating tools like Splunk, okay, those kind of things are okay. So it's kind of Agile is theory and DevOps is kind of okay, uh, having the tools to implement in practice. Okay, that's what you can imagine. Okay, that's what you can imagine. Okay, so Agile is kind of theoretical thing that is getting okay. All the principles talk about theory. Scrum is one implementation of okay Agile framework for people and process. Okay, for people and process, Scrum. Okay, I think I should put that here. Okay, quickly to improvise this. 1 minute, let me do that quickly. Okay, so Agile. Okay, one form of okay Agile is theory, right? Okay, and Scrum is an implementation of it. Okay, Scrum is an implementation of it. Let me insert insert. Okay, I'll change this. Mm, Just a minute. Okay, okay. So is Scrum is implementation of Agile principles. Okay, Scrum framework. Okay, now here DevOps is okay different. Is a little bit different, right? Compared to Scrum. Scrum is about people and process. Okay, I'll put that clearly here. It's about people and process. Okay, so now when we say DevOps, it's all about people, process, and tools. Okay, so people, process, and tools. So DevOps is covering the tools area along with people and process. So it's not only about tools, but it's also about working closely with people and following all the processes. Okay, it's kind of DevOps is an amalgamation of what is missing in Agile. Okay, what is missing in Agile? So like this, you can put it here. So it's combination tools plus, okay, DevOps is combination of tools. Okay, let me put this here. Very slow for some reason. 1 minute. Almost done. So it's about tools. Okay. Plus Agile plus Scrum, I would say here. Yeah. So DevOps is about tools plus process and people. Okay. So tools plus Scrum you can think of. Okay. So Scrum is talking about people and processes, customer focus and other stuff. Okay. Whereas, okay, I'll improvise this a bit later. Okay, I'll go one by one in 1 minute. Okay, I have to improvise this diagram a bit. Okay, let's go first this way. Okay, so DevOps is talking about development process improvement. Okay, now next one. Okay, so it will use different tools. As I told, development process improvements means it is going to use different tools to do that. Okay, like automation tools like Jenkins. Then we are going to use SonarQube. Then we are going to use Splunk. Okay, next, Agile preaches collaboration between stakeholders in a team. Okay, DevOps also preaches collaboration. Okay, because it's going to follow whatever Agile says. So it's okay. It's going to add more than what Agile says. Okay, it says more collaboration between development teams and operations team. That is the difference between this. Agile is not specifically talking about devs and operations, but okay, DevOps is saying okay, devs and operations teams too should work very closely. Okay, Agile framework for better collaboration. Scrum is one example as we saw. Okay, DevOps also suggests to use people and process. So Scrum is used plus automation. Okay, so this is the see, Agile is emphasizing on quality, okay, but it does not talk about how it has to be done. So DevOps talks about, okay, emphasis on automation, and it's mainly operations focused. This now Agile does not talk about this at all. Okay, operations it does not deal with operations at all. So DevOps deals with this. So that is another main difference. Both talk about customer feedback focused. Okay, when DevOps okay provides or suggests to have self feedback in every iteration, and for doing this, it is providing okay. It is going to have some tools to do this. Okay, tools to do this. Okay, in every iteration, the feedback can be provided by the tools automatically for you. That so the okay customer is customer here. Okay, so it's about end user. Okay, customer means end user here. But in DevOps world, okay, the feedback not only comes from the customer, but there are tools to provide the development teams some feedback about the quality of the code, the feedback about okay some issues that are happening in the code, the feedback about what are the improvements can be done in the code. So those kind of feedbacks, Agile will never talk about that. Okay, so that is what is another thing that okay Agile does not explicitly talk about, but DevOps will talk about that. Okay, so these are the main differences between Agile and DevOps. And now we know that Agile and DevOps are not competing with each other, but it's kind of an improvement or improved version of Agile, what it suggests. Okay, yeah, with yeah, that's correct, Richard. Agile tends to focus human-centric with less emphasis on tools, which is actually necessary for measuring human centricity. Yeah, you are right in saying that. Yes, you are right. So Agile is not talking about tools and other operational aspects, whereas DevOps is talking about that. So now DevOps and Agile works very well together to finally provide value to the customer. Ultimately, we have to provide value to the customer. That is our main goal, right? So now we are comparing how DevOps with Agile is going to help us, okay? And we are going to see how this is improvising our overall delivery timelines, okay? So with waterfall, we have seen this takes around 2 years of period, okay? Designing, then coding, testing, deployment. It takes around 2 years of time. Now with Agile, we are about people and process, no tooling, nothing, right? It only talks about people, process, and delivery, okay? So here, if you see delivering the work, okay, we are going to do design, code, test in every iteration. Then again, we take up some new task, code and test. Then again, we are going to do code and test. Finally, once everything is completed, finally, after some time period, we are going to deploy this to our customers. There is no shift left here. Okay, shift left is not, we are not talking about shift left at this point, because that thinking came with DevOps actually. Shift left thinking came with DevOps. So now DevOps, okay, and let me put that also, no shift left in here, okay. Uh, Let me put that quickly. Okay, with Agile, there is no shift left here. So that is no shift left thinking. Okay, with Agile, we don't have shift left thinking. So let me change the color. Okay, no shift left thinking. Whereas in DevOps, we have shift left. See, everything shifted left now. That means deployment is also shifted left. See, shift left thinking. That is the advantage with DevOps. Okay. Shift left thinking, no shift left thinking here. Okay, so this is the difference. I'll modify the diagrams a bit later, but yeah, no shift left thinking here. Whereas in DevOps with Agile, you can see that we do code, we do test, we do deploy, test. That means, okay, we are deploying every iteration to our development environments and treating this like a production. Basically, the idea is treating this like a production. Okay, treating this like a production. So that is the difference. That means we can deliver. If you are treating your development environment like production, that means you can take the outcome of this and deploy to your cloud at any time. Okay, you can deploy this to your cloud at any time. That is the thinking here. So any questions here? We have one more concept to cover before we close for the day.
Can we talk or we should type the question?
Sorry?
Can I ask or I should type in the question?
You can ask, yeah, go ahead.
Okay. Okay, I'm just looking at this DevOps with Agile. Did you say code design testing?
Yeah, code, develop, deploy. D means deploy. So I just put D, okay, for brevity purpose. I put, okay, let's
Okay,
say
so you
D.
mean code develop, is it develop or deploy?
Code means development. Code means development. Testing T. Deploy means deploying to an environment.
Okay, but why is deployment, why is testing coming after deployment?
Without deployment, we cannot test it. We want to treat it like, okay, deploy to your
I
environment
thought,
and then
sorry,
test.
I thought deployment is like you are delivering
Yeah,
what
we are
you've
delivering.
deployed, right?
Yeah, we are delivering here to our testing team to test it. So
Okay,
testers
okay,
are also
okay,
customers. Testers are also our
okay,
customers now.
okay, okay. So the deployment here is just for the internal people, not the outside
Yes,
user.
they're also our
Okay.
customers. That's why we are delivering to our internal customers first. We are treating this as a development environment, sorry, production environment. We are shift left now. Okay, we are doing shift left. You got it?
Sorry, sorry, madam.
Yeah.
Apologies coming to you. Actually, there's an interesting thought that I want to
Mm-hmm.
just that, and thanks for the good lecture so far.
No
There
worries.
is a testing. There's a testing after planning before you deploy, or there's a small validation that happens.
No, don't worry about that small validations. Okay, that developer will do that, what do you call smoke test or whatever that is. Okay,
Yes,
so don't
yes,
worry about that minute details, like that is not required, Richard. I
yeah,
appreciate you bringing this up, but it will confuse at this point. Later, anyway, people will
exactly,
understand. Yeah, but
exactly.
appreciate bringing that up. But I don't want to go into that very minute details here, because it will confuse the newcomers. Okay. Anyway, later when we cover the continuous integration, continuous deployment, we are
Yeah,
going to see those differences. Okay, minute differences. It's kind of okay. We are ready. Shift left thinking. What it is helping us with is we are trying to understand that we are making. Okay, the advantage is ready for production, ready for prod anytime. Okay, that is the advantage we have here. Okay, ready for production anytime. Okay, whereas in any of the other approaches, okay, if you see here in the above, we are ready for production at this point. We are ready for production at this point here. But in this, okay, in this model, we are ready for production every iteration. DevOps is helping us to do that. Okay, that's the difference between the previous methods and Agile plus DevOps method. Agile alone cannot deliver value continuously. It suggests delivering value continuously, but doesn't talk about tools, right? That's the problem with Agile. So that's when DevOps culture has come into picture, helping us to follow the people, process, and tools. Okay, combinedly, we can deliver value continuously to the customer. Okay. Okay. So yeah, there is one more last concept for today. Okay, so that you can go back and put some thought process while we join the next class. So that I want to cover this. The next class will be purely cloud. Excuse me 1 minute. Just hold on. I will have some water. Excuse me. Yeah, sorry for that. Yeah, now, okay. In the next class, we are going to cover mainly cloud computing concepts, and that's required for us to, okay, move forward. So that is next class. Okay, we'll purely concentrate on that. For now, okay, for today, we are going to stop our class after learning about different DevOps patterns. Okay, in real projects, different companies to work with, because every company is different. Every company will have different ways of working and different workforce, right? So they have different models that are being used in real world. Okay, so Bola, I'll come back to you. Just hold on to your question, or you can type it in the meantime. Okay, so the first model that is okay, the companies that are transitioning from normal traditional world to, okay, traditional world to this one, traditional world to DevOps world. Okay, so the first pattern normally they try is this one. Okay, where they have okay, they have domain teams where developers are there, and there is a dedicated operations team, and they try to bring these people together, and so that, okay, they want to create a shift left kind of a environment. Okay, where we have we have dev environment with production like scenarios. So In this model, what we are trying to do is we have separate development teams, separate operations teams, but we are trying to blend them together, and it is called blended DevOps model to achieve shift left here. Okay, the main agenda is to achieve shift left. We are blending these two team members together to achieve shift left so that we can create a shift left kind of an environment, and we can have our development environment as development environment we are trying to create as close to as production. Okay, so that is one model, that is model one. You can this is model one. Okay, so model one, basically we have two different teams. Okay, two different team members coming from two different verticals, and they're working together to achieve one common goal of creating development environment that is very close to production environment. Okay, so that is one model. Second model is, okay, it consists of all different types of team members. For example, this can be a developer, this is a tester, these two are developers, let's say, and this is DevOps engineers, and then we have product owners. All these people come together. Okay, these are cross-functional teams. Like, they're all coming together, and their main goal is to focus on delivering a application, and they are self-sufficient because we have different, this whole team together is self-sufficient. They don't have any dependency on any external team members because they have different kinds of people here. We have people who can test, who can do the operations, who can do the product clarifications of production, sorry, product features, and we have developers who can develop. Okay, this is a self-sufficient team. Okay, and they are optimized for throughput because everybody is involved in the team and they are going to discuss every day, and that means they're optimized for throughput and there are less number of handovers, and this is what is the ideal team for delivering value to our customers. And this is called cross-functional team because it has people from different domains and different verticals working together continuously every day using agile principles and agile and DevOps tools to deliver value to the customer. So this is another model. Okay, model number two. Okay, now coming to the third model. Okay, so this is like an extension to model one, model two, and this is okay. This is model one basically. Okay, companies have using model one, some teams using model one, and some teams using model two in a company. And in the company, we have an enterprise-wide DevOps team, okay, which is doing all these activities. It consists of devs with system or system admins with agile experience. So this team, basically, this DevOps team consists of devs with systems, okay, developers with systems knowledge. That means it's a developer with DevOps knowledge or DevOps engineers with agile knowledge. Okay, DevOps engineers with agile knowledge. So those kind of people will fall into this team. Okay, so with experience, like with a lot of experience in DevOps area, okay, you can, okay, after 4-5 years or maybe 6 years of experience, okay, you first start with these teams like model one or model two, and then you transition into bigger roles in a company by falling into this team. So this is this can be your journey. Okay, first you start with, let's say, this one, or because this model is not existing anymore, okay, you start your journey of a DevOps engineer with a model like with model two, then you slowly transition in your career to become one of the key members in your company in a bigger DevOps team. And their main focus is mainly automating the pain points across the enterprise-wide pain points. And they are responsible for building a platform that allows self-service by the teams in the organization. So whatever they are delivering as part of this team, it's kind of enterprise-wide solutions, not like individual team-wide solutions. They are going to focus on enterprise-wide solutions. And they're going to provide tool chains to enable devs to build, test, and deploy their systems. Okay, they're going to focus on different systems to enable devs to build, test, and deploy their systems. and they're also going to coach other teams in the company. So these are the three patterns that are existing in today's real world scenario. Okay, three patterns. Okay, one is shift left blended DevOps model. Okay, then cross functional team with shift left mindset already. Okay, so shift left is default nowadays. Okay, shift left is default nowadays. So there is no need to mention that explicitly, but shift left is default. Okay, shift left is default. Okay, shift left is default everywhere. So don't need to mention explicitly. Okay, so that is second one. Third one is this one. So these are the three models that are existing in today's world. Okay, Bola, you can ask a question now.
So madam, you've answered the question actually, so that's why I didn't bother typing it anymore. I just wanted to clarify about the shift left concept.
Okay, all good.
Thank you. Yeah.
No worries. Okay, so now coming to the DevOps skills. Now by this time you would have known already because we have covered some things in the past. But okay, these are the key skills that you need to acquire as part of this training. Okay, so why we are doing and what are the reasons why we are learning DevOps, and key concepts like microservices, monolith, and shift left. Okay, DevSecOps. Those are the concepts that you have to understand. Then next thing I told you already, by end of the course you should be practicing as many Linux commands as possible, and we have to learn so many DevOps tools that we have covered in the SDLC diagram there. Continuous integration and delivery, infrastructure as code, soft skills. All these things we are going to cover. Okay, infrastructure as code is Terraform. Okay, these are the skills. Coming to the best practices, okay, for any company that is delivering value to the customers, okay, they should have continuous integration. They should have continuous delivery. David, can you go on mute, please? Yeah. They should have continuous delivery. They should have monitoring and logging. Logging means Splunk. Okay. Monitoring is also part of Splunk. Infrastructure as code. Why this is required? This is required to monitor what is happening in your production. Okay, that's why it is required. Microservices based architecture. Then there should be communication and collaboration between your development teams and DevOps engineers. These are the best practices. Okay, for any company. With that, we are done for today. Any questions in any slide, feel free to ask. I'm happy to go back and explain it differently if at all you're not clear.
Yeah, I have a question here.
Yeah, go ahead.
Yeah, if you can go back to when you talk about DevOps skills, the two slides before now.
Yeah.
Okay. Yeah, continuous integration and delivery. But when you were showing us that end-to-end diagram, where you were talking about things that we are going to learn.
Okay. This one.
I think you mentioned that continuous integration tools will not be taught in the class.
Yes, that's correct. Yeah.
So how are we going to be able to have such knowledge if that is not taught?
Olu, you are there in the last class. We have done this. You remember Jenkins and Azure DevOps? So let me try to go there. Yeah. Okay. So we have done. Yeah, we have done Jenkins and Azure pipelines. You remember?
Yeah.
This one. Yeah, that is what is going to cover continuous integration, continuous delivery.
Oh, okay. Okay.
Okay.
Okay. Thank you.
No worries. Any other questions, anyone, before we close for the day? I hope the pace is okay for newcomers. If any problems or anything with respect to speed, anything with respect to the examples or anything with respect to the material. Yeah,
Hello?
Go ahead, Peter.
Yeah, good morning. My name is Peter.
Yeah,
So
hi,
I'm
Peter. How are
just
you?
joining for the first time.
So I actually don't know where you guys are, where you started from, and where you are.
Peter, I will give you one. Yesterday, we had one class before, but that is not the real class. It's like introduction class. So
Okay.
you are there from the beginning of this class?
No. I just joined not long, like 20 minutes back.
Okay. All good. Anyway, Lakshmi asked you to join here, is it?
Yeah, Lakshmi, yeah.
Okay, that's fine. I will send you the recordings for the previous class and today's class. Okay, we just spend some time. Tomorrow is holiday anyway for you. So your number is ending with 8651.
No.
Can
My
you
number
ping me?
ends with 346.
346.
Yes.
Yeah. Okay, got it. Yeah. So 726346. Last few numbers, right?
Yes.
Okay,
Sorry, I want to
Peter.
ask, how far have you gone in this
Today
class?
is the first class. Today is it's done for today. But
Because
I will
I
send.
just overheard you talking about CI, that you're not going to be teaching CI that has been taught before.
No, we are going to teach CI. We are going to teach CI.
Okay.
I was telling we are going to teach CI using Jenkins and Azure DevOps. Both.
And Azure DevOps. Okay.
Yeah, both. So I think you missed this slide. Okay, let me go back. This slide you missed, I think. You were not there
yes.
at the time. So yeah, we are going to cover CI and CD with Azure DevOps and Jenkins. That's what I was telling Olu.
Okay.
Okay, I'm just going to make a note of your number. So you are going to continue, Peter?
Oh,
Peter
yes,
Patrick.
I will. Yes.
So yeah,
I sent Lakshmi a message. I
okay.
actually, I want to have a one-on-one with him.
All
However,
good.
I want to continue, but I'll still want to
Okay.
have a one-on-one.
So we'll add you to the group. First thing we have to do, because you might miss some notifications. So first we'll add you to the group. Then we will send you we will send the recordings, Google Drive where all the recordings exist. Okay. So you can cover during tomorrow. So its last class was 2 hours and this class is 2.5 hours. So you have to, and our next class is on Tuesday. Tuesday is what? Okay. Tuesday is 12th, I think. So yeah, next class will be on 12th. So please finish before that.
Okay. All right.
Okay.
Yeah. Thank you very much.
No worries. All good. Okay. Anybody else new who did not get a Google Drive link, etc. in this group?
It's just Rick. I'm still. Please don't forget to send that welcome email with those links. Bring them. Okay.
So I sent it already. Bullrick0@gmail.com. It was sent already.
What is up?
It is sent. Yeah, it is sent. Yeah, it is sent. Rick. Rick, right?
Yeah.
Let me show you. Let me show you. Oh, what happens is it goes to spam. Can you check it once, please? Yeah.
Okay.
It might be in your spam. I sent it twice already.
Okay.
Let me show you that anyway, quickly, so that you will be confident. 1 minute. Yeah. In the sent, I'm searching here with your email ID. Yeah, see? It's already sent twice. Yeah.
Okay. Let me look into.
Yeah, all good. Kumar, I will send it to you. Nitish. Okay, 1 minute. Yeah, go ahead. Sorry, Nitish.
Yeah, so the mail that you've sent, right? In that, I see that there's another thing called AWS test account.
Yeah.
So do we have to keep that ready by the next class?
Not required. I will tell you when, maybe in 2 classes it is required.
Okay.
So you're not right now. Okay.
Okay, that's okay. Because it was mentioned that probably to go through the register mail and password, but then when I try to log in, it says it's not registered. So probably I'll just.
Yeah, that's correct. So I'll make them ready by in next 2 to 3 days. Okay. So don't worry. So that is the link. You have to keep it for future, but not now.
Okay.
Anybody else who are supposed to get that welcome email? Only new students will get the welcome email, not the old students. Okay, old students can access the direct link, Google Drive link, because new students require everything in one place. That's why we send that. But old students anyway, they would have had the welcome email. So Kumar, I've sent you the welcome email. Can you check it once? Yeah, Didi,
I had a
yeah,
I
go
had a
ahead, sir.
question. So
Mm.
with the AWS
Mm.
learning that we have to
Mm.
do on the recording, is it on the email, the link?
So if you have made the payment completely, then only you'll get that
The
Derek, right?
AWS. Okay.
Yeah, AWS is like an add-on we are giving. We'll give only once all the payments are completed, not right now. Let's say if somebody has completed, I think Bola has completed, looks like. Bola, you can request for the AWS. Send me a message and I will give you access to the AWS recordings, Bola.
Okay.
Yeah.
Thank you.
So like that few students who have made the complete payments, you'll get that. Whenever you make a complete payment, please let me know. I will give you some advanced materials and other stuff, okay?
Hello, madam. Hello, madam. Can I also request now?
Yeah, Richard, yes, please.
Okay,
Please
thank
ping
you.
me and give me 1 or 2 days once you request, okay? So I need to sort out
Okay, then.
check few things, but please request, okay? You can request.
Okay, thank you.
Yeah. So apologies, Didi, that's a value add, so we cannot give right away. Okay, sorry for that. Yeah. Anything else before we close for today? All good. Thank you everyone for your time and have a nice weekend. Thank you everyone for joining. Thank you. See you in the next class on Tuesday, which is on 12th of November. We'll see you. If anything in between, please ping me. Feel free to ping me in the group. And also please join our Telegram group. Let me ping you the Telegram group link right away once again. Whoever not joined, just hold on. Okay, Telegram group link I will give so that we can, so that you are not missing out on any of these notifications. Okay. Thank you, Thierry, and you also stay blessed and enjoy your weekend. Okay, I pinged you the Telegram link. I'm bringing once again in our. Thank you, Felix, and have a nice weekend. Enjoy the time, everyone. Happy learning.
Thanks, Melvin. Have a good weekend.
You have a good weekend. Thank you, Nitish. Where are you from, Nitish, by the way?
I'm based out of Melbourne.
Oh, Melbourne. We are same place then.
Yes.
Okay. Yeah.
Okay.
Okay then. Bye-bye. See
Thanks,
you
Melvin.
all. Thank you. Thank you, everyone. See you all. Bye-bye.